All right, guys, quick review over acids and bases. Like I said, this should be a review from chemistry, possibly even from middle school. If you guys have not gotten here yet in chemistry, you will. I just need you to have a real basic understanding of the difference between the two. So an acid is going to be anything that's going to increase your hydrogen ion concentration. So anything that is increasing your hydrogen ions. So they're going to have a little bit of a positive charge. So anything that increases the hydrogen ions in the solution is going to be acidic. And things that are acidic are going to be lower on the pH scale. The pH scale goes from 0 to 7. So anything that is acidic is going to be down on this end. The lower the number, the more acidic it is. If you look here, 5 is black coffee. 3 is soda and vinegar. Down here at 2 would be the stomach, the acid that's in your stomach. So the lower the number, the more acidic it is. A base, or something that is alkaline, is anything that will increase, it'll pick up your hydrogen ions. So it will decrease your hydrogen ion concentration. A lot of times it will release OH ions. And so those have a negative charge. So those would be attracted to the hydrogen ions, and so it would pick them up, and it would form water, which would therefore decrease your hydrogen ion concentration because it picked up the free hydrogens that were in the solution. Things that are alkaline or basic, they are on this end of the pH scale. So these are 14 being the most basic. So the higher the number, the more basic. The lower the number, the more acidic. 7 right here in the middle is neutral. Most biological things range from 6 to 8 at the most. You'll notice 7 there, pure water, human blood, tears. Inside of the small intestine, seawater is a little bit basic. Where urine, saliva would be a little acidic. So buffers are going to be things that are able to resist our change in hydrogen ions and hydroxyl ion combinations. They are going to be extremely important in biological systems. Your body has a significant number of buffers in it that help it maintain your pH balance. And a buffer is usually going to contain an acid-base pair that can be reversibly combined with the H+. So when it becomes too basic, it can release some of the hydrogen ions. When it's too acidic, it can easily pick those hydrogen ions up. So let's look at an example of how that will happen in the ocean with the acidification of the ocean. So what we have over here is the human impact situation. So this burning of the fossil fuels here to fly the jet plane, that releases CO2. As hopefully we remember from our freshman year with the carbon cycle. So when we burn the fossil fuels and we release the CO2. And so that CO2, about 25% of that burned CO2 ends up here in the ocean. And when it ends up in the ocean, it will dissolve into carbonic acid. So that's what we have here is this carbonic acid. And so that carbonic acid, the acidification is going to occur because these hydrogen ions would dissociate. And so when these hydrogen ions dissociate, they're increasing the acidity of the ocean, which would actually be lowering the pH of the ocean. And so these hydrogen ions will combine with carbonate. And so that's what's happening here. This is our carbonate. So these hydrogen ions combine with the carbonate and they make this bicarbonate solution here. And so that bicarbonate is going to help act as our buffer. Carbonate, the one here with no hydrogen, carbonate is required for calcification. Lots of our marine organisms need carbonate, in particular coral, to be able to form its shell. And so the bicarbonate can act as a buffer. When need be, it can release the hydrogen. And when the ocean is too acidic, it can pick this hydrogen up here, it can pick these free hydrogen ions up and form the bicarbonate. And so that's how it's going to act as a buffer system to help this ocean acidification keep from getting out of control. So another example that we have here would be another human impact example affecting pH of things would be acid rain. So again, it's going to come back to our burning fossil fuels. And when we burn fossil fuels, we release sulfur oxides. So we release sulfur oxides and nitrogen oxides. And these sulfur and nitrogen oxides, they are going to react in the air with with the air that's in the atmosphere, and they are going to form acids. And when the air becomes more acidic, when these acids are formed in the air, those acids will come down as precipitation. Okay, so essentially the sulfur and nitrogen oxides that have been released in the air, they produce these acids. Okay, and usually acid rain is going to be anything that is below a 5.2 acid level. You can see here, here's where rainwater is. Okay, it's right at about 5.2 on our pH scale. And so acid precipitation would be anything that is more acidic than that. You can have mild acid precipitation, and you could have significantly stronger acid precipitation, where if you actually went outside in the rain, it would sting because the rain is so acidic. And acid rain or acid precipitation, because it could come down in the form of snow or sleet, can have a major impact on the living systems on the earth. You know, it can acidify bodies of water. It can have an impact on plants by changing the acid levels of the soil. Okay? It can obviously have an impact on the animals because it can be painful and corrosive to them as well. Okay, so just another example of how human impact can have an impact on, can make a difference in our pH balances. Okay, so that's really all I need you to know about acids and bases. I really need you to understand that acids are going to increase our hydrogen ion concentration. Bases are going to lower that. I need you to know your synonym for bases, that alkaline means that something is basic. I need you to remember on your pH scale, you've got 0 to 14. The lower the number, the more acidic. The higher the number, more basic, with 7 being neutral. Most of our biological systems are between 6 and 8. And I need you to understand that a buffer is going to be something that's going to help mitigate those changes. It's going to help minimize the changes between our hydrogen ion, those fluctuations within our hydrogen ion concentrations, okay, which are going to be extremely important in our biological systems.